Hey, my name is Zach, and I'm here to tell you how we can use manipulatives to better increase our ability to tutor students in the math lab. So we've all had a scenario like this. Somebody comes into the spa, and they come up with a question like x squared plus x squared, and when you ask them for an answer, sometimes you'll get one like this. You'll get x to the fourth. And we know that's not right. But sometimes explaining that to a student can be a nightmare. So I'm going to show you how we can use manipulatives to visually show the student how this problem will work clearly and concisely. But in order to do that, I'm going to need to go back to the basics. So let's start with this guy right here. I'm going to call him 1 unit. So if I were to introduce more of this guy, I can clearly see that I have 1 unit in each of these areas. So to count them up, 1, 2, and 3, that means I have a total of 3, and that is how addition works. We can see 1 plus 1 plus 1 equals 3. But let's say I have a situation where I have somebody I don't know. This bar will represent an unknown number of units. So I don't know how many units he is. I don't know how many. I could guess. I could try to figure it out by approximating. But let's say I don't want to just guess. Let's say I want to work it out in a way that is useful to me. So I'm going to do that by calling him x. I'm going to give him a name. His value is unknown. He's x. And let's, in the similar scenario where I had the 3 known units, I'm going to have 3 unknown units. All of these guys are the same length. So it's x. So in a similar sense, I have 1, 2, and 3 x's. So that is going to be equal to 3x. Now, what happens if I go ahead and try to bring together known values with unknown values? Well, in order to do that, I'm going to demonstrate with a little bit of real-world material. So let's say that I have a donut, okay? And then somebody else gives me a donut. So now I have 2 donuts, okay? Well, then let's take that donut again. And this time somebody hands me $1. Well, I have a donut and I have $1. I don't have a donut dollar, just a donut and $1. Similar thing is going to work in the case of x and our numbers. So let's say that I have x. This guy is x. And then I have 1. And I'm going to add these together. Well, they're not from the same thing. In the case of our donut and $1, these are 2 separate things. So when I add them together, all that occurs is I have a donut and $1. I have an x and I have a 1. So, bring that back. In this case, I had x plus x. 2 unknowns. These guys were both unknowns. They were both donuts. So I had 2 of them. I have 2 x's. So to continue along with solving the problem that we were working with, I need to introduce the concept of multiplication. So let's go back to the unit with my 1 unit guy. Well, let's say I have 3 units again. So that's 1, 1 for a total of 3. Well, what happens if I go ahead and bring in 2 more groups of 3? So, 2 more groups of 3 for a total of 9. So that means that I count these up. 1, 2, 3, 4, 5, 6, 7, 8, 9. That means I have 9 units there. So 3 groups of 3. And through multiplication, I can see that that is 9. 9 units. Now what happens if I go ahead and put these guys together in what's called a square? So if I put them together in a square, I can see that I have a scenario where the height of the square is 3 and the top is also 3. So we can say that 3 times 3 can be expressed as 3 squared, which gives us also 9. 9 units inside of the square. Well, now let's say that just like before, where I had an unknown length of units, I have an unknown square of units. So here is our unknown square of units. Again, I don't know how many units are in that square. But if I take my two x's here, in the same sense where I had 3 high and 3 along the top, I have x and I have x. This is x times x, otherwise known as x squared. The square is made up of the units, the unknown unit lengths of x. So that brings us back to where we started, where I had x squared plus x squared. And here's another x squared. So I'm going to add them together. Well, if you notice, in the case of our donuts, these are both the same thing. They're both squares. So I had 2 donuts when I had 2 donuts, right? So in this case, I have 2x squared, so this will be 2x squared. So that's how we can do this. We can visually show that we have 2 squares here that we demonstrated how they could be measured as unknown units of x squared, and then we can combine them together as 2 of the same groups as 2x squared. And that is going to make it a lot clearer to the student. It's going to give them a visual that's going to work wonders in their understanding of this subject.
Beautiful.